In section 10.7, we're going to solve equations that are in exponential or logarithmic form. We've already done some of these, but in this section, they're a little bit different. So in 10.3, we solved an equation such as this. And to solve that equation, what we did was we took the 8 and we changed it so it would have the same base, because 2 to the third power is the same thing as 8. And then what we did was we set the exponents equal, and we got that x would be 3. So if x was 3, we would get 8. However, in this section, we're going to do the same thing, but this time, when we solve this equation, we can't do that. There's no way to make the bases the same on both sides. So we're going to learn how to solve ones like this. So we have some steps to follow. The first step is we are going to isolate the exponential expression to one side of the equation. So if we take a look at example 1, we want the exponential, so that means the base and the exponent all by itself. So with problem 1, we can skip step 1. It's already isolated. Step 2, we are going to either log or natural log both sides. Now, it doesn't matter which one you use, but typically we use the natural log if in the problem there's an e, if the base is an e. So step 2 is, since the base is a 2 and not e, we're going to log both sides. So I'm going to put a log on both sides of the equation. So I put a log on both sides. So that's step 2. Then step 3 is we are going to apply the power rule for logarithms to make the exponent the coefficient of the log. So we learned this in section 10.5. So step 3, we're going to use what we learned in 10.5 in your notes, that we could take this exponent and put it in the front. So this is step 3. Okay, so we put this out in front there. Then the very last step is we're going to solve the resulting equation. So when we solve an equation, we want to get x by itself. So to get x by itself, this says x times log 2. So instead of multiply, we're going to divide both sides by log 2. So x equals log 10 divided by log 2. So now we're going to go ahead and evaluate this here. So we know in this class that if it doesn't have a base, it's a 10. So if we take a look at the numerator, this is saying 10 to what power is 10? So this numerator right here simplifies to 1. Now this one is a 10, so 10 to what power is 2? There is no nice number, no whole number, integer, so we're going to keep it as log 2. So this is our final answer here, but we wouldn't tell someone, oh, x is 1 over log 2. People would be like, well, what number is that, right? Just like we wouldn't tell someone, oh, the area of a circle is 2 pi, we would not want to know what is that about. So now you're going to take your calculator and you're going to go ahead and enter in 1 and then divide it by log 2. And in the directions here in your notes, it says to round to 2 decimal places. So your calculator will show something like 3.3219, etc. So 2 decimal places. So we're going to look at the third number, and it's not 5 or higher. So that means 1 divided by log 2 is about 3.32. Okay, so if we wanted to check if this answer is right, keep in mind that we rounded our answer to 2 decimal places. So if we were to take out the x here, we were to get rid of it, and we were to replace it with our answer that we got here, 3.32. So if you take your calculator right now and enter 2 to the 3.32 power, you will get about 9.98. So it's not going to equal exactly 10 because, again, this was rounded. But these two should be really close. So remember, when you're done with your answer, if you want to check it, you replace the x with the answer that you got. Alright, so example 2. So we look at our steps. The first step is to isolate the exponential expression. So here's the base and here's the exponent. We want to get this all by itself. So just with our normal linear equations, to do that we're going to first start with getting rid of the minus 4. So we're going to add 4 to both sides. Okay, so again, our goal is to get this by itself. So now we're going to divide by 6. And now we have step 1 now completed. So all of this was step 1, isolating the exponential. Then step 2 is we are going to log or natural log both sides. Remember, whatever you do to one side, you have to do to the other. Now, since this is e, we're going to natural log both sides. So that was step 2, natural log both sides. Then step 3 is we are going to apply the power rule. So we're going to move this x to the front. And then we're going to go ahead and solve the resulting equation. So to get x by itself, we're going to divide both sides by the natural log of e. So we now have x equals the natural log of 12 divided by the natural log of e. So now let's see if there's anything here that we can simplify. We talked yesterday that if the base here, we know that if it's a natural log and there is no base, it's an e. When these two are the same, when this is the same and this is the same, that it cancels and it makes 1. Because remember, this is saying e to what power is e? So 1. So in other words, we have the natural log of 12 divided by 1, and anything divided by 1 is just itself. So we get the natural log of 12, and the directions say to round that to the nearest hundredth place, so to 2 decimal places. So go ahead and enter that into your calculator, and we would get about 2.48. Okay, so if we take a look at example 3, again, our goal is to get this by itself. So we're going to go ahead and start with dividing by 3. Then step 2, we're going to go ahead and log both sides. And then step 3, if there's an exponent, we're going to bring it to the front. So we'll have, and we need to put parentheses around it because the x plus 1 is together. Okay, then step 4 is solve the resulting equation. So we're going to go ahead here and we're going to divide by log 2. And then to get the x by itself, to get rid of the plus 1, we're going to go ahead and subtract 1. So, giving us the final answer, x equals log 6 over log 2 minus 1. And then we could check to see if log 6 or log 2 could be simplified, which it cannot. So this would be our exact answer, and then our direction says, in addition, round that to the nearest hundredths place, 2 decimal places. So in our calculator, we would do log 6 divided by log 2, get an answer, and then do minus 1. And we would get about 1.58 for x. All right, example 4. The first step, we're going to isolate the exponential, which it already is. So step 2, we're going to go ahead and log both sides. Step 3, we're going to apply the power rule, so we're going to bring this to the front. Step 4, we're going to go ahead and solve the resulting equation. Now we're trying to get this x by itself. So this 12 here is being multiplied by the x, and this x here is being multiplied by the log. So we know when we have an equation like this, okay, a linear equation, that when everything's being multiplied, the 2 and the x is being multiplied, to get rid of the 2, we would divide by 2, leaving just the x equals 4. So just like we do that, with this log here, it's the same thing. I know it kind of looks weird because we're not used to seeing log in an equation, but this is a number. So you're technically dividing by the 12 to get rid of this, and the log 1.05. And we're dividing all of that, and that's going to cancel out, leaving us just with the x. And whatever we do to one side, we have to do to the other side. So our final answer, we'd have log 2 divided by 12 log 1.05. And then if we enter this into our calculator here, we would do log 2 and then divide it by, and put it in parentheses, 12 times log 1.05 divided by that. And you should get about 1.18. All right, so first step, we want the base and the exponent by itself. So we're going to get rid of the 4. Next step is we're going to go ahead and log both sides. And step 4, we're going to go ahead and move the exponent to the front. And the last step, to get this x by itself, we're going to go ahead and divide everything. Since this is multiply here, we would divide. Because again, remember, as weird as this may seem, that's just a number. So we're going to divide by log of 0.6. So our exact answer is log 3 over log 0.6. Then we're going to enter that into your calculator, and we would get about negative 2.15 for x. All right, last problem like this. So we're going to isolate the base and the exponent. So to do that, we have to get rid of this 5, and it's being added, so we're going to subtract 5. 43 minus 5. Okay, next step is we're going to go ahead and log both sides. And then we're going to move this to the front, the exponent to the front. Since it's x minus 2, we have to put it in parentheses. So we remember that that whole thing is being multiplied by the log in the front here. And now We're going to go ahead and divide by log 7 to get rid of that. Now we have x minus 2 on the left side. And our goal is to get the x by itself. So since the x, it's x minus 2, we're going to go ahead and add 2 to both sides. So that gives us that x is equal to log 38 divided by log 7. So you would enter that in your calculator and then add 2 to that. And we should get about 3.87.